Alright, so the next thing I will need to teach is about the free body diagram. Okay, so for free body diagram, basically it's just labeling of all the different forces acting on the object. Okay, so let's just say for example for this aeroplane, we have 4 forces. So we have the thrust, we have the lift, we have the weight, and we have the drag. D for drag lah. But of course, the layman term is what we call the air resistance. Okay, so all the forces must be labeled accordingly. Yeah. Then for this second diagram is the box, right? We have the tension, we have the weight. Right. Okay. One very important thing about free body diagram is that we do not label the resultant force in a free body diagram. Okay, so let's just say I have a car. Okay, and this car is accelerating forward. So we have a driving force, we have a frictional force. I just put it F. And of course, not to forget all your weight, and of course your contact force. Contact force maybe I just write here. Normal contact lah. Okay, so these are all the different forces acting on the object. But we know that the car is accelerating forward, but we do not label the resultant force. We do not label this. Okay, so that's a very important thing. Right. Okay, so yeah. Okay, free body diagram basically also help us to calculate what is the acceleration, or what is the forward force or the weight of the object. Right. Okay, so yeah, so drawing free body diagram can help us find tension, contact forces, the magnitude of the different force. Okay, alright, so let's try some of the different cases. Alright, so if we have one object system, how do I calculate what is the direction of the resultant force, the acceleration? This one is simple, but when it comes to two body problem, that one is the difficult one. Okay, so for case 1, we have one body system. Resultant force definitely is just 10 Newton. Okay, direction is towards the right. Since your acceleration is, so since we know that F equal to ma, right? F is equal to 10, your m is equal to 2, hence your acceleration is equal to 5 meter per second square. And of course, your direction of your acceleration must always be in the same direction as your resultant force. That is something that we must take note of. Okay, next, same thing, but now we have a frictional force of 4 Newton. So the resultant force should be 6 Newton. Direction of resultant force is towards the right hand side. Acceleration, we know resultant force is 6, right? Divide by 2, you should get 3 meter per second square, because F equal to ma. Direction of acceleration, same thing, towards the right hand side. Okay, next, so we do not have any resultant force, right? So just put 0 here, 0 here. Okay, yeah. So this is one body problem.